This is section 3.1, part B. Here we're going to be doing some modeling with quadratic functions. So we're going to be doing quite a bit of regression. The first question, I've got the data for years and motorcycle deaths in thousands, and the scattergram has already been drawn for me. So my first question is going to be, is it better to use a linear function or a quadratic function to model this data? So to model the data, I'm going to want quadratic because I can see the general shape of a parabola in the data. I can see that it is decreasing and then increasing. So that's going to be my reasoning here. So quadratic because the data is changing from decreasing to increasing. Okay. You also could, if you were interested, you could do both regressions, linear and quadratic, and compare to R-squared values. But I can see from the shape of the graph that a quadratic should fit the data better. That doesn't mean it's going to extrapolate better, but it does fit the data better. Okay. Now I want to find the quadratic regression model. So I am working, as you can see right here at the beginning, at years since 1980. So that means I'm going to enter the t-values 5, 10, 15, 20, 22, 24, 26, and 28 into my stat menu. So we need the stat key, go into the edit, up to the very top, clear, up to the very top, clear, and then enter your new data for this question. So 5, 10, 15, 20, 22, 24, 26, 28, and then 4.6, 3.2, 2.2, 2.9, 3.3, 4, 4.8, and 5.3. Okay. I always like to just look at it to make sure I haven't typed anything wrong. So I turn my plot on and I do a zoom stat. And that's what my data looks like. It does kind of compare to this. Now my window isn't exactly the same, so it doesn't look exactly the same. But I do see a pattern that fits what this one looks like. So I'm feeling comfortable with that. Okay, now back into the stat menu, over to calculate. This time we want quadratic regression, which is option 5. So I'm going to go down and hit calculate. You can see the a squared value is negative 0.019. The b value is negative 0.603, and the c value is 7.14. I also can see the r squared value, which I'll write down in a second. So first, m for motorcycle deaths equals f of t is the a value, only two places, okay. So it would be negative, no, positive there. So it would be it was 0.19, so 0.2. T squared, then minus 0.60, t plus 7.14. Okay. The r squared value on my screen was 0.97. I guess if we're on two places, it'd be 0.98. Oh, it says 3. Oh, gotta read more carefully there. I saw 2 on that one. So 0.9758, so 976. Okay. Explain how you can verify the model fits. That's because my r squared value is close to 1. Right? The r squared value of 0.976 is close to 1. That is a verification that my model fits the data well. Alright, on the next page, hopefully I get to use this model to make a couple predictions. So I'm going to try to write the model up on the top of the page real quick. It was my m equals f of t equals 0.02 t squared minus 0.60 t plus 7.14. So we're going to use that model when I make the predictions. Part E, f of 25. So f of 25 is going to have us plugging 25 into the model for t. So, clear. I'm going to have 0.02 times 25 squared minus 0.60 times 25 plus 7.14. So that gives 4.64. Okay. Remember from the previous page, the years were since 1980. So if I add 1980 to my t value, the 25, That is going to put us in the year 2005. So we'll write our sentence. In 2005, there were 4.64, I gotta look at the previous page for units, 4.64 thousand motorcycle deaths. All right. Now, that's what it means. The last piece of this question is, was it interpolation or extrapolation? So I'm gonna look again at the previous page from my data set. 25 as an x value is in between two years that were part of my data set. That means that it is an interpolation. It is in between data that I've already been given. So this one was an interpolation because 25 is inside the data values for x, for t. All right, letter F asked me to find f of t equals 8 by calculator. Okay, so if they want me to find it by calculator, what they want me to do is take my original equation and intersect it with 8. So I'm going to go into my y equals menu, and we're going to graph the equation, 0.02 t squared, or I have to use the x key, minus 0.60x plus 7.14. Then I'm also going to graph 8, and I'm going to see what this looks like. So first I'm just going to hit graph and see if it shows up. This is my curve, my parabola. Now 8, I don't think is going to show up because my scale isn't high enough. So I'm going to go into my window. 8 was a y value, and I can see down here that the highest y value is 5, so I'm going to make it 10 just so that 8's in the middle of the window. I also am going to need to increase and decrease my x min and max. The min was currently 2. I'm going to go ahead and try to make that negative 20, and I'm going to make my max 50, just trying to shove that window further out so that I can see a range around the graph, so I'll be able to see the points when 8 shows up, see the points where it intersects the graph. Okay, so now I can see the value for 8, and I'm going to do second calc option 5 for intersect, enter to select first curve, second curve, and then just move closer to one than the other. So the first one gives me an x value of negative 1.37. So I'm going to make my sketch real quick. So this first x value, or t value, is t equals negative 1.37. And the next one, once again, back to the calculator screen, option 5 in the calculate menu for intersect, enter for first curve, second curve. Before you hit enter and guess, make sure you're at least halfway over to the second one. That gives me an x value of 31.37. So that's my t value over here. So t equals 31.37. Okay, what does this mean in the situation? Okay, these are both years, and remember that these are years since 1980. So I'm going to want to add 1980 to both of these for the interpretation. So if I take 1980 plus 1.37, that's going to put me in the year 1978.6. So I'm going to be in 1978. Again, you can just take on your calculator if you would like. You can take negative 1.37 plus 1980, and you see that you get 1978.63. Okay, so my explanation will be in, I need both years, that's the first one. So in 1978 and in 1980 plus 31 is going to put us in 2011 if you add those up. So, and in 2011, there were 8,000 motorcycle deaths. And it makes sense that we have two such years because the number of deaths had been decreasing and then it increased again. Okay. Part G, find the vertex of the model by calculator, include a sketch. What does it mean? Okay, so I still have the graph on my calculator, so I'm going to go into second calc. I can see from the picture that it's going to have a minimum. So the vertex is going to be found by either maximum or minimum, depending on what shape I have. It's going to be option 3 for minimum. And I need to move it to the left side of the vertex before I hit enter. So left side, hit enter, then back over to the right side of the vertex, hit enter, then hit enter again for the guess. And so it tells me the minimum value is the order pair 15, comma, 2, oops, I almost started writing the y value first, 15, comma, 2.64. Again, that word vertex is a word that can mean either maximum or minimum. We say vertex when we're not sure which one it's going to be, but once you see the graph, you know it's going to be a minimum, and you use the calculator feature to find the minimum. Okay? All right, so in this case, this is the minimum, and 15 is your years since 1980, so that's going to mean you're going to be talking about in the year. We had 15 to 1980, that's 1995. So in 1995, say something about the fact that it is the vertex, i.e. is the minimum. So the minimum number of motorcycle deaths occurred, and that minimum number was 2.64 thousand. The minimum number of motorcycle deaths occurred, comma, at 2.64 thousand. And once again, when I write this sentence, it is important that I give the year, that I mention the fact that it was the vertex, i.e. the max or the minimum, and I give the value that occurred during that year. Okay. Flip to the next page. Okay, this is a calculated recap about how to find the vertex, or max or min. And you have to identify it first. Your graph has to be ny equals, ours already was. Then second calc, then you choose either option 3 or 4 for max or min. Left bound, right bound. So you have to stop it all the way on the left, hit enter, all the way to the right, hit enter, guess, enter again. Okay, the next example is going to have us looking at the median age of first marriage for men and for women. So we're going to want to find two functions. Judging from the scattergrams, which have already been done for us, is it better to use linear or quadratic functions to model this data? Okay, well, both of these, I can see a pattern of increase, decrease, so it's going to be better to use quadratic functions to model this data. That's what I'm going to write here. Okay, so quadratic for both functions because they change direction. So both functions change direction from increasing or from decreasing to increasing. So they both change from decreasing to increasing. Another way to phrase that is that they both have a parabolic shape. Okay. It is possible that one of your graphs would be better fit by quadratic and the other one better fit by linear, but here quadratic would be my answer to both. Now, I want to find quadratic models for both using regression. So I need to enter the data in. This is since 1900, so we're going to use 40, 50, 60, 70, 80, 90, 100, and 110 for the year values. We're going to list 3 columns here. Okay, so stat, option 1 calc, up, up to clear, enter, up to clear, enter. 40, 50, 60, 70, 80, 90, 100, 110. Okay, I'm sure that you can type these. Oh, I started typing the wrong ones. I'm going to leave those back out. Let's go to L2. 24.3, 22.8, 22.8. Okay, then 23.2, 24.7, 26.1, 26.8, and 8.2. My lists are different length. Oh, there, I made a mistake. 70 and 80. That one is 70. This one needs to be 80. Then 90, then 100. Trying to type them very fast. that you don't have to watch me typing them for so long, but I have a lot of data to enter here. Okay. Okay, hopefully all my data is in there correctly. I'm going to do a quick check because I don't want to have any mistakes in my data. So I'm going to clear out the previous equation, turn on my plot 2 as well, and I'm also going to go into stat plot to make sure that plot 2, instead of L1, L2, has L1, L3. So I hit second, then the numeral 3 to get to L3. Then I'm going to do my zoom stat. So I'm going to see both graphs at the same time, and you can see that the blue one is the men and the red one is the women, so hopefully that matches up, and they look very comparable to the two graphs I saw, one higher, one lower. Fantastic. So I have typed it all in correctly. Now I want the two models. So stat, calc. Okay, so quadratic regression, remember that L1, L2 is the default, and your calculator remembers what you did last. So I'm going to do the L1, L3 first so that I can change it to L1, L2 next, and in my memory on my calculator screen will remember the default. So L1, L3, let's go down to calculate, and that is the women. So W of T I found first. My model has 4 places, so 0.0019 T squared minus 0.2045 T plus 26.125. Okay. I also want the r squared value, so I'm just going to write that off to the side. The r squared value is 0.95. Okay. Also going to do the men's. So now second calc regression again, option 5. Change your L1 and L2 back to the default so that next time you have L1 and L2 already in there. Now we'll do the men's equation. And you can see my values, 0.0018 is the first coefficient. Unfortunately, we can't see the calculator screen at the same time as I'm writing, but I have 0.0018 as my t squared value minus 0.2060t plus 29.01, I'm sorry, it was 00178, so 0018. And this one has an r squared value of 0.93. So again, both have very high r squared values. They're very close to 1. What does it indicate? So this indicates, these values both indicates that both models are very good. So both models are a good fit. Okay. Use the models to predict when the median age of first marriage will be the same for men and women using the window below. Okay. So hit window. I'm going to change this window manually to match. So it's going to be 0, 250, 20, 0, 75, and 15. The rest of it can stay the same. Then hit graph. You can see your data sets are very close together now. Your first model should be showing up soon. Well, it would if I had remembered to type it in. My bad. So I'm actually going to calculate those one more time. So stat calculate option 5. L1, L3, and in stored regression equation, if you hit alpha trace, it's going to give you the fast way to enter those. I'm going to hit option 2 to put Y2 in there so I don't have to type it in myself. Then I'm going to go back to stat, calculate option 5, L1, L2 this time, store regression equation, alpha trace, bring up that list again, put it in Y1, and then calculate. Now I have my models in Y1 and Y2. You could type them yourself if you didn't want to hit those buttons, but for me it was faster to hit those buttons than it was to type in those models. So now I'll hit graph, and hopefully my regression equations will show up this time. So there's the first one. That is the men's equation in blue, and in red in a second comes the women's equation, and I want to find when these are equal. It was helpful that they gave me the window because it's really far away with their equals. So I'm just going to do a second. Calc option 5, enter, 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 and I find the intersection point at 198.55, 60.61. Okay, so draw a sketch, it says. So my equations look like this, where the intersection point is at the ordered pair 198.55, comma 60.608 or 61. Okay, and that now I need a sentence. Okay, this is years since 1900. So if you add 1900 to 198, that would give you in the year 2098. So in 2098, men and women will have their first marriage at 60. So both men and women will have their first marriage at age 60. So it's kind of a joke, but this is the actual prediction at age 60.6 or age 60. We know that the average age for first marriage has been increasing, so if the patterns continue, the age at which both men and women get married is not going to be, or it's going to be 60 in 2098. All right, I think that is the end of this section. Oh, I've got an optional problem. Never mind, let's continue. This is the one where I do it by hand. Okay, so if I solve this one by hand, I need to write down the models. So finding the first marriage age by hand, I need to set the two models equal to each other, right? So I want W of t equals M of t, or vice versa. And the models, I can kind of see through my paper, so let me see if I can write them down. So W of t was 0.0019 t squared minus, I need to flip my page over to see, 0.2045 t plus 26.125. And I need to set the equal to the men's equation, which was 0.0018 t squared minus 0.2060 t plus 29.0018. Okay, so if we're going to solve this by hand, it's going to be a pain. What I need to do is subtract all of these terms over to the other side to get it equal to 0. So we're going to subtract the 0.0018 t. We're going to subtract the, or add in this case, the negative 0.206 t, and we're going to subtract the 29.0018. So we're going to start with 0.0019 minus 0.0018, which is going to give us 1e to the negative 4, that's scientific notation, so for 0.0001 t squared. Then I have to take negative 0.2045 plus, because I'm adding this to the other side, 0.2060, that's going to give me plus 0.0015 t. And finally, 26.125 minus 29.0018 gives me negative 2.8768 equals 0. Now, since this isn't factorable, I will have to plug this into the quadratic formula if we're going to do it by hand. You're starting to get the reason why we did this one in the calculator to begin with. So if I'm going to solve for the t value, I have to use my quadratic formula. So negative b, so negative 0.0015 plus or minus the square root of b squared, so 0.0015 squared, minus 4 times a is 0.0001 times c is negative 2.8768, all divided by 2a, so 2 times 0.0001. Okay, so that's negative 0.0015 plus or minus. I'm going to do this part all in one step since I want it decimal anyway. So square root of 0.0015 squared minus 4 times 0.0001 times negative 2.8768. It's inside the square root already because they just care about the decimal anyway. So I have 0.03396 over 2 times 0.001 is 0.0002. Separate. Do the addition and subtraction separately. So I do the addition. My numerator becomes negative 0.0015 plus 0.03396 So my numerator becomes 0.03245 divided by 0.0002. Or if I did the negative subtraction, it would have been, just put the subtraction in there, it would have been negative 0.03545 divided by 0.0002. Okay, so I finished my division. The first number, up to hit that first number, 0.03245 divided by 0.0002 is 162.25, and the other one, negative 0.03545 divided by 0.0002 is negative 177.25. Now, 2 points about this. First of all, is we only got one answer in the previous page, not two. We should have gotten two. We just ignored the one that was before 1900. There is another solution over here somewhere. We just didn't find it. Okay, so because we were only looking for the few prediction, because basically 1900 was the start of any history we cared about in terms of the data for men and women getting married. So this one is really far in the past. So this would have been in the it would have been in 1900 plus, would have been 1722. Okay, so in 1722, something happened. We don't know. We can find out in a minute. But that would have been so far in the past. Now, this one would have been in 2062. And I just want to point out right now, before I find out what happened in 2062, that that's a very different answer than I found before, which was in 2098. Now, which one is more accurate? Remember that I used the exact model. Remember, I put the model itself without rounding in y1, right? So y1 equals the unrounded because I put it in the stat calculate menu, which means this is much more accurate. Because these are rounded even to 4 places, because these values are so small, even rounded, this value is off quite a bit. It's 162 instead of 198. Okay. Had I plugged in individually each of the original equations, I should have gotten the same thing. So you could check that. Type your equations that you wrote down into y1 and y2. Find the intersection. You should get the 162. Okay. Now, what does it mean? To find out what it means, I have to plug the 162 back into the original equation, either one, M or W. So plug it into W. So 0.0019 times 162.25 quantity squared plus 26. Nope, sorry, that's the next coefficient already. Minus minus 0.2045 times 162.25 last plus 26.125. So this gives us 42.9 as the y value. So this was 162.25 times 42.9. So this means that in 2062, both men and women don't get married until they're 42.9 years old. So men and women first marry at 42 years. Okay. The reason I'm not finding the other one, and you could if you wanted to find it, but we're not going to find this one because remember that the graphs were such that you're going to have a very high value over here and compared to these other values over here, and you're going to have a very high first age of